Hi everyone. I've gotten a few questions needing some help on the scale factor and area project that was posted this week. So here is a quick help video just reviewing both concepts so you can go ahead and complete that project. As a reminder, that project is done in Classkick. Please make sure that you're putting your full first and last name in order to receive credit for this project. This project, the goal is to complete a riddle at the end. So your answer on every page will give you a letter. That letter, then you will take that to the number slot on the riddle page, and you can type in your answer, and then that will fill in your riddle. So it is a two-word answer to that riddle. Let's go ahead and review some of the concepts that are in the project so you can be super comfortable. The first thing that you are asked to do in that project is to find the area of composite or compound figures. So a composite or a compound or even a complex figure, all that means is it's a figure that is made up of two or more shapes that you can decompose, find the area of each, and then bring them back together by adding them all in. So here's an example of what a compound or composite figure could look like. In order to solve this, I am going to split it up into two different shapes. Now, it's important to note that sometimes there's more than one way to split something up. So in this situation, this is an example where there is more than one way to correctly split up this shape. So I'm going to go ahead and split this shape right here. Now that I've split it right there, I've got two different rectangles that I'm working with. So I'm going to look for the dimensions of each rectangle. This is important. My first rectangle, the formula for area of a parallelogram is the base times the height, also known as the length times the width. So I'm looking for two dimensions. I need the lengths of two sides in order to build the area. So the area for this top rectangle, I have a width of 6 feet here, as can be seen by the top, and then the height of this rectangle is 2 feet. So I know that the area can be calculated by multiplying 6 times 2, which is 12. So the area of this top rectangle is 12 feet squared. Now I can go ahead and work on the area for my second rectangle. Now this one is a little bit different because I have been given the dimension down here of 3 feet. So I know that at the bottom, that's 3 feet. However, I need to calculate the height. So I'm going to use some clues. It says over here that the total height is 5 feet, and then this height over here is 2 feet. That means that this side right here has a height of 3 feet. So I can go ahead and multiply 3 times 3. That equals 9 feet squared. So now that I have the area of my top rectangle and the area of my bottom rectangle, I can go ahead and add these values to combine. So I've got now 12 feet squared plus 9 feet squared is a total of 21 feet squared. So again, when you're working with an area of composite figures, split the shape. There's more than one way that this shape could have been split. Find the area of each in order to solve. Here's another example of finding the area of a complex compound or composite figure. Now in this one, there's a little bit different because we've got two different shapes. We need the area of a rectangle or a parallelogram, base times height, but we also need the formula for area of a triangle. And the formula for area of a triangle is 1/2 times the base times the height. So I'm going to go ahead and use both of these formulas to calculate the area of both. My bottom rectangle, 12 by 18. And I'm going to use my calculator to solve that. 12 times 18 is an area of 216 yards squared. Now I have the triangle. So my formula is 1/2 times the base times the height. So the height of my triangle is 7. So, and the bottom dimension, the base is 18 yards. So I can multiply 7 times 18 is 126. And then I can go ahead and multiply that by 1/2 or divide by 2. It's the same thing. And that gives me 63 yards squared. So again, whenever you're dealing with a triangle, make sure that whatever you're calculating, base times height, then you half that because the area of a triangle is half of the area of a rectangle. Now that I've got my two dimensions or my two areas, 216 yards squared for that bottom rectangle, 63 yards squared for my top triangle, I can add those together and those give me a total of 279 yards squared. So again, you're splitting up your shape differently. So this one was pretty easy to split up. The last example, we had to physically split that shape up in order to calculate the total yardage. And then always make sure that you're using the appropriate formulas. If it's a parallelogram, base times height. If it's a triangle, 1/2 times base times height. Now let's talk about scale factor. So I do have a formula at the top, and these notes have already been provided for you. They're already posted in your content so you can see them. But the formula for scale factor is a measurement from image 2 divided by a corresponding measurement from image 1. That's super important. People often make the mistake of just going larger divided by smaller. That will not always give us the appropriate scale factor. So when we're talking about enlargement, this is a shape that grows in size. So it's when a shape starts small and then gets bigger. And that means the scale factor is going to be greater than 1 because all the side dimensions were multiplied by a number greater than 1 to make it grow. Now, if we have reduction, this is when a shape starts large and becomes small. So the shape is shrinking, and that is a scale factor between 0 and 1. So again, if a shape is getting smaller, then the shape has to be multiplied by a number smaller than 1 in order for all the dimensions to shrink. So let's take a look at some examples here. I've got two triangles, and this triangle started small and is getting bigger. So this is an example of enlargement. So because it's enlargement, we know that the scale factor has to be a number greater than 1. Again, if it starts small and it gets bigger, that means all the lengths were multiplied by a number greater than 1 in order to make that shape grow in size. So I don't have dimensions on these triangles. I'm just going to make it up. Let's say that the bottom measurement for this triangle is 4, and the bottom measurement for this triangle is 32. I'm going to use whatever my formula is. Again, it is the measurement from the second image. So in this case, my second image is the larger one. That has a measurement of 32. I'm going to divide that by the measurement from image 1. So again, it's not smaller or bigger, it's image 2 divided by image 1. The measurement for image 1 is 4. So here I have 32 divided by 4, and that gives me a scale factor of 8. So that means for my smaller triangle, all the dimensions of my smaller triangle, when multiplied by 8, will give me the dimensions of the bigger triangle. And here's another example of scale factor. And this one is an example of reduction. So we had a rectangle that was larger, and then that rectangle became smaller. So this is an example of reduction. Now, from what we talked about on that note slide a few pages ago, whenever we're discussing reduction, the scale factor is a number between 0 and 1. Because that is what would make a shape shrink. So again, I don't have dimensions on these, just gonna make it up. Let's say the dimension for this one is 40, and let's say this one is 10. I'm gonna use the same formula I did before. The dimension from the image 2, so here we go, image 2 is 10 divided by the dimension from image 1, 40. When that simplifies, that gives me a scale factor of 1/4. We can check our reasonableness with this. We got an answer of 1/4. Does that fall in the range of 0 to 1? It does fall in the range of 0 to 1. A scale factor of 1/4 is smaller than 1 but bigger than 0. So that is a dimension that would, or a scale factor that would make our shape shrink in size. So that's all I have for this review for scale factor. So as a reminder, when you're going through the project, there's no account to create. You're just going to sign in, or just click the link and put your name in there, full name, and then you have 7 questions to solve. Your solution to each question will give you a letter. You're going to use that letter in the slide 10, I believe it is, to fill in and answer the riddle. I will also have a help session on Tuesday for anyone who still needs assistance after reviewing this review video and after working on that project. I hope you have a great day and thank you for watching.